This protocol allows for the creation of materials previously non-existent in nature, with the goal of either uncovering formerly inaccessible physical phenomena or developing superior devices for technological applications.
The main advantage of this technique is that the equipment can be operated remotely and in an environment controlled, and this can reduce the risk of manual error, and also it can improve the sample cleanliness. Furthermore, the system is equipped with a rotational stage, and this allows the user to reach sub-degree angular alignment between the two flakes.
As we are working with thin crystals and small surface areas, identification of an appropriate size flake can be challenging to the untrained eye. Additionally, the crystal's small size can easily lead to misalignment during the transfer procedure. Therefore, it is recommended to execute these steps meticulously.
Many steps in the protocol have particular details that are difficult to explain, but they're much simpler to follow when presented visually.
In order to visualize the transfer process, utilize an optical microscope that can operate under bright field illumination. Equip the microscope with 5x, 50x, and 100x long working distance objectives. The microscope must also be equipped with a camera that connects to a computer. Equip two separate manipulators, shown here, to individually control the position of the crystals. Fabricate custom sample holders that can support a glass slide. This sample holder will be used to position the top crystal. For the bottom manipulators, place a flat heating element in a machined glass ceramic holder and affix it to the rotating stage. Then, connect the heating element to a power supply and a temperature controller. Submerge a 1 by 1 cm